Hello, folks. My name is Nikhil Manchanda, and I'm the project technical lead for OpenStack Trove. And today, I'm going to take this time to tell you a bit more about OpenStack Trove, who we are, what we do, and how you can contribute to the project yourself and be part of the community. So let's get started. So let me start actually by telling you a story of how Trove sort of came to be formed, right? So in a previous life of mine, I used to be a developer at a corporation, and anytime we wanted to write an application, most applications need databases. So we'd have to stand up a database. And in order to do this, I'd have to literally talk to the sysadmin team and tell them, hey, can you guys set up a database for us? And then they would send me this Word document, which basically would go through a couple of pages with what sort of database do you need, how much space do you think it would take, how many people would be using it, yada, yada, yada. And we'd go back and forth a few times trying to figure this out. And so by the time you'd actually get the database and you could get your application using the database, it would at least be a week or a couple of weeks' time. So this sort of, with the advent of cloud computing and us having resources at our fingertips, this old model of provisioning databases didn't make any sense to me. So OpenStack already did a great job of provisioning compute resources and provisioning storage. But the next step, taking the leap of going from that to provisioning actual databases that my application could use, that's something that Trove's involved in. So that's basically what this project started off to do. So I want to start by just going over the Trove mission statement as we have it in OpenStack Trove. And it briefly states to provide scalable and reliable cloud database as a service provisioning functionality for both relational and non-relational database engines, and to continue to improve its fully featured and extensible open source framework. Now there's a few salient points that I've sort of highlighted in blue there. We want Trove to be scalable so that as your application grows, we can grow the database underneath it and meet your application's needs. And importantly, it should be reliable as well, so that if there are failures, and we all know things in clouds will fail, we'd be able to sort of recover from those failures so that your application would keep running. Also, important to note that Trove is a database service provisioning functionality. So Trove doesn't really get into the data layer of things. So you tell Trove you want a MySQL database, and Trove will provision one for you. And after that, your application directly talks to MySQL using the MySQL data layer, the MySQL APIs. And Trove doesn't come in between there. Today we started off supporting relational databases with MySQL, but we support MySQL relational and non-relational databases. So we also support a whole range of other databases like CouchDB, MongoDB, Cassandra, and we also support Postgres today. So also, very importantly, Trove is an OpenStack project. It makes use of other OpenStack projects underneath the covers, and it's completely open source. You can go to the OpenStack repositories and check out the source code and take a look at it and see what's actually going on underneath the hood. So now that I sort of went through the mission statement of Trove, just want to give you a sort of analogy of what exactly Trove is. So if you think of a vending machine, so if you think of databases being sort of products from this vending machine, you walk up to this vending machine and say, hey, I want a MySQL database. Can you give me a MySQL database? And then Trove provisions this MySQL database that you then gives you an IP to. You take that away, plug it into your application. Your application keeps working with it. But it's not just that vending machine database. It's something more. So Trove is also manages sort of the life cycle of that database. So for example, let me give you a couple of examples how Trove does this. So it's involved with things like backup and restore. So for example, if you want to make sure that your data on the database is backed up, Trove will kick off a backup process depending on what kind of data store you have and what backup strategy you set, and then store that database data to Swift. And then you can restore a new Trove database later on based on that backup data. Trove also helps with tuning your database in certain at an API level so that you don't have to monkey around with my.conf settings on the actual VM. So there's sort of lifecycle management of things that Trove does to make this easy for you as well. Wanted to talk a little bit about the Trove architecture. So if you look at this slide, I know there's sort of a lot going on there. But the important pieces here are the stuff on the left of the slide are basically components of Trove itself. So we have the Trove API, the Trove Task Manager, and the Trove Conductor. And on the right, we have this components of OpenStack, the other components that Trove depends on. So Trove boots up its VMs in Nova. You can put your database data on volumes in Cinder, take backups to Swift, and Trove uses Glance to actually store its database images. We also make use of Keystone for identity and Nova networking and Neutron for networking. So the basic architecture of Trove, once an API request comes into Trove, it hits the Trove API. The Trove API then says, oh, I need to spin up a MySQL instance, for example, puts the information in the Trove database for the request, and talks to the Trove Task Manager through the message bus, which is usually RabbitMQ, some sort of AMQP message bus. And then the Task Manager is where sort of all of the magic happens. The Task Manager looks up the MySQL guest image in Glance, talks to Nova to provision the guest, talks to Cinder to set up a volume for the MySQL data files, and basically puts all of this together and gets the Trove guest agent up and running. Once the Trove guest agent is up and running on a VM, the guest agent itself has a concept of heartbeats. So it talks back to the component called the Trove Conductor and says, hey, I'm up and running. You now have a MySQL data store that's functioning. I've verified this. And you can change your status to active. And so if you pull sort of the Trove API, your new MySQL instance status flips to active. So in a nutshell, that's sort of what's going on under the scenes. Also wanted to talk a little bit about how Trove is built. And Trove is really built to be modular. When I mentioned Trove has support for these different data stores, right? So for each one of these data stores, we have what we call a guest agent in Trove. And so we have a MySQL guest agent, a Postgres guest agent, a MongoDB guest agent, and so on and so forth. And depending on the type of data store you request in your API, that guest agent gets loaded. But not just that, within the guest agent itself, the guest performs different operations, things like backup and restore. So we have different kinds of strategies for those operations. So in this case, for example, we're looking at a backup operation. And if we take the same sort of MySQL example, you'll notice that MySQL itself has two different strategies for the backup operation. So we have the MySQL dump backup strategy, which basically uses MySQL dump as a tool under the covers to create a MySQL backup in Swift. Or you could also use the InnoBackup EX strategy, which basically uses the Percona extra backup tools, InnoBackup EX, if you're familiar with that, to take a backup as the database is running and sort of stream that to Swift. And then you can use that, the corresponding restore strategy with that, to do a restore of the database. So everything is sort of built modularly, so it can be extended by just creating another module or another strategy to have your kind of backup that you want to include in Trove. Question that I get asked really frequently, where can I get Trove? And my most frequent answer to that is, well, use the source. We're part of OpenStack, and so all of the Trove source code is with the places where all the other OpenStack projects have their code, which is git.openstack.org, which is also mirrored on GitHub. So that gives you a convenient sort of user interface to actually get to the source code. How do I get started with Trove once I have the code? As a Trove user, probably installing Trove, your easiest way of getting it is through a distribution that packages Trove, such as HP Helium Development Platform, or you could also get a Trove distribution, such as a Tesora DBaaS platform that's just Trove specific and doesn't package the rest of the underlying OpenStack components. As a developer, this is interesting. So Trove has a bunch of Trove integration scripts that makes lives for developers easier. So you could clone that from the Trove integration project. And then if you wanted to get Trove up and running in your development environment, you'd have to do a red stack install, followed by a red stack kickstart, the kind of data store that you're trying to get up and running. So in this case, the example, it's MySQL. We also recently added Trove as a plugin to DevStack, so you could clone the Trove OpenStack project and enable the Trove plugin in your DevStack local RC, and that way if you just wanted to kick the tires with Trove, get that install up and running as part of DevStack, that workflow works really well as well. So, just wanted to talk through certain things that you can do with Trove, some of the basic operations of Trove. You can provision a Trove instance with Trove Create. We have support for flavors, so you could create, depending on whether you wanted a micro Trove instance or all the way to a 2XL, and you can define what flavors you want. We also have support for volumes, so you bring up a Trove instance and you say, I want my database to be 50 gigs large, and that would sort of provision a 50 gig volume with Cinder and attach that to your database and then store your data files on that Cinder volume. There's optional parameters. We have support for availability zones using availability zones, the -- availability zone flag, and that needs to be enabled underneath with Nova and the Nova scheduler filters. There's also support for neutron networks using the -- nic parameter that works pretty much the same way as the -- nic parameter works in Nova. I spoke a bit about backup and restore. Just wanted to go through a quick example. So to create a backup, it's simply Trove backup create. And then you could also, you have optional parameters. One thing that we recently added was support for incremental backup, so you're not doing a full backup every time. You could say, hey, I already created a backup yesterday, use that as my parent backup, and create this backup incrementally on top of that. Trove also supports sort of replication. So if we're talking about MySQL instances, so Trove master slave instances, you can create a Trove replica instance based on a master, and you'd sort of use the same Trove create workflow. You'd pass in a replica of and another Trove instance ID, and Trove underneath the covers would go set that up for you. We also introduced the concept of clusters in Trove, and this is sort of the new and upcoming feature of Trove. We currently support just MongoDB and Vertica clusters. We added MongoDB support in Juno, Vertica support we added in Kilo. We're talking about adding, there's a lot of discussion sessions about adding Galera support coming in Liberty, and we're hoping to land that this next cycle. Also, I want to say we're a growing community of contributors, 130 plus contributors from more than 28 companies, 2,047 commits, and lots of lines of code. We're always open to new ideas, and if you can find us on hash OpenStack Trove on Freenode and IRC, and there's always lots of room for improvement. Come talk to any of us at the summit. We have design sessions, the fishbowl sessions on Wednesday afternoon, and design sessions on Thursday. So please come to us, bring your ideas, bring code, we're happy to have you. So thank you very much.